After watching that video, you probably have a lot of questions about how an undersea data center ever became a real thing. Well, our next guest is here to answer those questions and more. He is the manager of Microsoft Research's Project Natick. Ben Cutler is here. Thanks for being here.
Thanks, Chris. It's nice to be here.
Before we jump into the questions, we would like to present our latest poll question to the audience, get their reaction. You weigh in, and then a little bit later, you're going to reveal the actual answer. So this one, you're actually being tested on, ladies and gentlemen. So go ahead and weigh in. Here is that poll question. What's the dominant background noise in the ocean? You could go home and test your kids with this one tonight. Is it whales, dolphins, seals, other sea mammals communicating? Is it B, shrimp? Is it C, waves crashing on the coast? Or is it D, noise from ships, submarines, other human activity? Is it us? Or is it something in the ocean? Weigh in and we will reveal those results before you know it. So let's start by talking about the project at large. What is Project Natick?
So, Chris, Project Natick is basically an exploration of undersea green data centers and the benefits that we think we might yield from the idea of a standard manufactured, easily deployable data center. And so an example of one of the benefits we see is rapid deployment. It takes today as much as 2 years to build a data center. So with this sort of an approach, we might be able to get a data center in place in 90 days. Wow. So that means respond rapidly to our customers. It also means support for one-time events. So for example, if we wanted to take a data center just to a World Cup, or on a more sober note, sometimes humanitarian relief efforts require a lot of compute capability. We might be able to support them as well. Another advantage is getting close to our customers. It turns out that half of the world's population actually lives within about 120 miles of the sea. And so by putting these data centers offshore major population areas, we can actually bring that compute power a lot closer to customers than they are today.
Wow.
That could benefit you, for example, if your kids are playing Minecraft at home, or if, for example, I'm a CEO and I've got some important application my customers use backed by the cloud, it'll be more responsive to them. A third thing that's really important to us is sustainability. So we imagine in the future these data centers offshore, producing, using clean, renewable energy, for example, offshore wind, not emitting any carbon, not putting anything into the environment, and being 100% renewable. So at the end of the deployment, we pull it off the seafloor and recycle everything and leave the sea as we found it.
Wow. Talk about how this project was initially conceived, and then how do you convince the appropriate people that this is relevant, this is needed, we need to do this?
So this thing started with a very colorful individual here named Sean James. He's a data center designer today, but earlier in his career, he was actually a submariner for the U.S. Navy. So from those long days on submarines with not a whole lot to do, I think he learned a lot about the ocean. He brought that knowledge with him when he came to Microsoft. And so he was thinking, we've got these big data centers, what sort of challenges we have. And so he understood that maybe there's an opportunity here. So he and one of his colleagues published a white paper internally that found its way to Microsoft Research, where I worked, and we're now exploring whether this is a viable economic reality. Wow. As to kind of why we care about this, it's the cloud. So the data center is actually, that we build actually are what support the cloud. The cloud, as you know, is everywhere. It's growing exponentially. And so, for example, Microsoft today offers more than 200 cloud services, and we've spent to date more than $15 billion on our cloud infrastructure.
Wow.
So we're always looking for ways that we can deploy data centers faster, at lower cost, and with greater environmental sustainability. Project Natick is simply one of those projects that we're exploring as a way to do that.
Now, boil it down a little bit in terms of how Project Natick works. So what are the technologies at play?
So I think the thing that people always think about is cooling. Today, data centers, we expend a lot of energy to keep servers, the computers and data centers cool. One thing people may not know is even if you go to very warm places on the planet, like the tropics, if you go deep enough in the water, it actually gets cold. And so one of the things we look to is inexpensive cooling as a benefit of this. And relative to a typical data center you might find today, we can reduce the amount of energy for cooling by as much as 95%. So it becomes practically free to cool data centers when we put them in the ocean. How we do this technically is actually pretty simple. So in a land data center or a Natick data center, what happens is the servers are there, air flows through them to keep them cool. In our case, that air comes out hot and hits a heat exchanger, which is basically like your car's radiator. And in this case, it will cool the air down. The heat then goes into a liquid loop that flows between that internal heat exchanger and one that's outside the data center in the ocean, and it's cooled by the ocean water. So it's very simple. It's kind of what your car's engine cooling system works, but kind of the inverse. Here we're using cold water to cool the hot air. Another thing that we do is there's no people in this sort of a data center, so we can change the atmosphere. And in our case, we remove the oxygen and the water vapor. And what that means is some of the chemical processes we have on land, like corrosion, happen very slowly or not at all here. And so that should lead to longer server life and greater reliability.
Wow. What are the primary benefits of technology like this?
So I think, in addition to some of the things like sustainability and rapid deployment, one of the things that we should talk about is the end of Moore's Law. And so for the last 50 years, we've had electronics advance very rapidly. And as a result of that, we're always wanting to buy a new computer or a new phone. But we're reaching the end of that cycle. And what that means is the cadence at which we replace servers in data centers will probably slow and perhaps dramatically. So we envision a future where we may have these data centers on the ocean floor operating lights out. There are no people there. And with great resilience, possibly for as long as 10 years before we replace them.
Wow. Now, obviously, pioneers are remembered for their accomplishments or their discoveries, but if you ask them, they probably remember the roadblocks, the headaches, the things that didn't work.
Right.
Talk about what you've learned from the undertaking of a project like this.
So I think the first thing we learned is that we could do this. And this, is, as you might imagine, is a very different thing than Microsoft typically does. And it was really a team effort, both within the company and with our partners, to be able to pull this off and demonstrate some of these benefits that we've been talking about today. I think because it's remote and we can't reach out and touch it, we had sort of an Internet of Things of sensors on the data center down there, so we could monitor things remotely. So we could tell you how warm it was, how fast the air was flowing, how much power we consumed. We also had microphones outside the data center, what are called hydrophones, to listen at the data center. And the reason was we're very concerned that, for example, we don't emit noise that's harmful to sea mammals or other sensitive sea life. One of the things I think we all learned a lot about was the environment under the ocean. And I think we were all really surprised, as you saw in the video, how quickly it was colonized by sea life. This is this notion of artificial reefs, when humans put something in the water and nature takes over. And that's something we'll be studying more as we go forward.
This is exciting stuff, and you provided a great segue there about being aware of our effect on the ocean, even just from the noise front. We want to circle back to our poll question, and we'll see what people thought, and then you can reveal the real answer. Remember that poll question? Here it comes, ladies and gentlemen. We're talking about noise in the ocean. What is the dominant background noise in the ocean? Do you think it was whales, dolphins, seals, and other sea mammals communicating? Was it B, shrimp? Was it C, waves crashing on the coast? Or was it D, noise from ships, submarines, and other human activity? Will we be the guilty party?
Wrong.
It says D, and I will admit that is what I assumed, but you say that is not correct. Almost half of the audience says it's got to be us, right?
So it turns out it's shrimp. And snapping shrimp are the dominant sound in much of the ocean as they snap trying to catch dinner. And if you listen carefully at that video toward the end where you see the crab moving, you can hear this crackling noise.
Yeah.
And that's the shrimp in the immediate area of the data center.
Wow.
So yeah, it's very surprising.
And the best part is that your kids are at school, so you can go home and teach them this and pretend that you knew it all along, ladies and gentlemen. File that one away. We love that.
Very good.
All right, so talk about what's next for Project Natick.
So coming up next for Project Natick is the first phase was basically proof of concept. Could we actually do this? So the next phase is demonstration at scale. And so one of the things we've been spending a lot of time on, Chris, is thinking about global supply chain. How do we actually build out a supply chain that would allow us to meet our goals for cost and rapid deployment? And so as we think toward this next phase, probably in the next 12 to 18 months, we'll have the next vessel in the water, and it will have probably 10 to 20 times the number of servers the first time around. We'll be in deep water rather than relatively shallow water, and we'll probably be in the water for at least a year, maybe longer.
Wow.
On the renewables side, this notion of sustainability, we really want to take to the next level. So we expect that we'll deploy somewhere that will actually be powered by offshore energy. That might be wind, or it might be some of the new marine renewable energy technologies like tide or wave. I think it's worth noting that inside the company, we're doing lots of things with data centers. Some of them are just sustainment to improve what we already have in the field today, but we have a number of very innovative projects like Natick that are exploring really transformative advances that, if they work out, will provide benefits both to us and to our customers, and in a sustainable way.
Well, you just hit on at least the general topic of what a question from our audience here. Matthias wrote in on Twitter, and you can write in as well. Just use our hashtag, and you can join the conversation. He says, any chance that the power will come from the water moving around the container itself to be self-sustaining? And it sounds like that's kind of part of the possibilities?
Yeah, so I think what we've seen is with renewable energy, we've seen wind and solar happen. And now what's happening is the ocean versions of these. So the first is offshore wind, which is often better than land. We can much stronger winds, and they're much more sustained. But then the motion of water, both from tides coming in and out, is one form. And another place is just the motion of the waves on the surface is another form of energy people are learning now to try and capture. So yes, we definitely see that in the future.
We're just about out of time, but what's one thing you'd want folks watching to know? We've got thousands of people from all over the country watching, and maybe some of them are hearing about Project Natick for the first time. What would you want them to leave and go tell their friends? Hey, have you heard about this?
I think I'd like people to take away that we're trying to do these innovative things because we're interested in not just sort of going down the road that we've been on for a long time, trying to understand new and different ways to do things, either to help the environment, to help our customers, and basically sort of be good stewards of the world that we leave to our children.
Great stuff. Well, we appreciate it and we wish you well. Thank you for sharing all of that with us today.
Chris, thank you very much for having me.
We appreciate it.